Good morning, everyone. Welcome to my talk, Approaching 3D Environment for Mobile Devices. This is me. My name is Saurabh. I am lead 3D artist at Super Gaming. One of my key responsibilities at Super Gaming is to create a performant workflow and performant game assets without compromising the qualities of the Indus game. Next, we have to tackle environments. So I am a gamer myself. Whenever I take screenshots of any of the games, I just do a breakdown. And most of the times, almost 80 to 60% of the screen is filled with environment, which is a massive deal. Environment in itself has a lot of components. There are terrains, there is architecture, there are rocks, there are foliages. So how do we tackle something massive like this? We start off with understanding what are the challenges we'll be facing in mobile development. First off, let's start with the targets. We need to have some kind of baseline for our targets to understand what are the decisions we are going to take in order to achieve goal what are we setting for ourselves. First is hardware. What kind of hardware are you going to target? There are multiple kinds of hardware. It ranges from low end to high end. You can just have a range of targets or some baseline devices in which you will be projecting throughout the journey of your game. Second, we have genre. What kind of genre are you targeting? Is it an open world game? Is it a shooter? Is it a TDM? Whatever it might be, it has its own set of challenges. For example, Indus is a battle royale. We have to stream large amounts of assets and large amount of players are going to be playing it. It is very difficult when compared to a closed game environment in which you can just populate the game with high fidelity assets and not worry about the performance. Next, we have performance. What is your lowest baseline device FPS you are targeting? Generally, it is acceptable for most modern devices to have 30 to 60 FPS, but at Indus, we like to have it around 45 to 60. So yeah, that is your target device for most of the baseline device. And from there, you can just move forward and have 60 FPS on targeted devices. Later, scalability. It is a very important aspect of art to be scalable. Suppose you want to port the game to any other devices or consoles, etc. Your art track should be scalable so that it can support all the scalable devices and won't have to worry about redoing the entire art. Okay? Next. Next, we'll look at some of the technical constraints which come with the mobile devices. First is poly count. Poly count is something that you will hear a lot about in gaming industry. You have to be considerate about polygons. What is your poly budget? So what is poly budget? Poly budget is not essentially the budget which is given to entire environment. It is poly budget per frame. Number of polygons you see on screen per frame. Next, we have object density. Object density essentially is how many objects are populated at a given moment inside your scene. This can vary based on level design, so you'll have to coordinate with them. Third is the texture count. Texture count is essentially how many textures you are using inside your game. These can vary based on game to game. You can have large amount of textures, low amount of texture, or even have atlases. Next is shaders. Shaders are essentially the base of your game. These will be the components that will be rendering all of your objects, all of your textures, all of your materials inside the game. So having a complex shader will give you liberty to have any kind of art style at the cost of your performance. Moving forward, let's look at two of the main components we need to understand as an artist. First is the poly budget. What are the factors that affect the poly budget? Some of the key factors we don't consider while creating assets is like the UV splits, number of islands, etc. These all add up to the vertex count inside game engine. First, we have the base mesh, which you author inside the DCC application, and any other data which you include inside the vertices will additionally add on to the engine side of the things. Moving forward, next is the texture budget. This is a very subjective term as it essentially relies on the VRAM of your target devices. This is when you need to have a baseline devices. If you have a baseline devices, you can gauge like how much textures are you going to be able to push forward inside your game. Having a baseline devices will also help you manage in the size and overall workflow which you will be taking forward to approach the texturing workflow. Also, one of the key things to consider is what kind of textures you're going to have inside your game. Because it is recommended mostly to use opaque textures. It will help you with the performance, as having alpha can cause overdraw and will eventually be more resource intensive and cause you performance like drops. Okay, so now we'll be talking about how we approach the production of environment inside Indus. So this talk will be mostly focused on the authoring side of thing, not the technical side. We will have some technical bits there to test your game later on. So first and foremost, from the production standpoint, we just start off with the asset breakdown. There are some assets which are essential for the game, which needs to be there inside the game without any other attachments, etc. So these are the assets which we call gameplay assets. These are the core assets which will always be there. Next set of assets are the art style defining assets. These are the assets which give your game the identity. So for Indus, we have Indo-futurism. So we have some assets which are just there to define the Indo-futuristic vision which we have for Indus. And next set of assets are the auxiliary assets, which are there just to support our vision in conveying what we are trying to convey to the player. These assets can be culled down as we scale from low-end to high-end devices or high-end to low-end devices. Moving forward, one of the key things we need to find is what is your asset balance. You need to complement the complex geometry with the simple geometry, as reducing the overall vertex count will help you in performance gains later on. Also, at Indus, we do have an extensive list of things which we do in textures rather than in geometry. This, in turn, also helps us in reducing poly count. Okay, now we start with the authoring. This is just a rough rundown of what we do at Indus. So first foremost, we need to identify what kind of workflow we are going to use. Workflow is very essential, and we need to understand like what kind of workflow you are going to use for your game. Unique will essentially be each asset tackled uniquely. You have its own UV and limited iteration. Second is the kit-based workflow, a modular workflow in which you have multiple kits. The complexity is all about how many kits you can produce. Third is the hybrid, which we have in Indus. We need to have identifying pieces uniquely authored, which have its own identity. And the core pieces are authored with the modular approach, which we can swap and iterate as fast as possible. Next, we have authoring tips. So most of the artists at Indus have to follow some of these things in order to get the performance boost. First is split. Splits are generally used to cull out the geometry which is not in view of the player. So having your multiple splits in your meshes will help you to reduce the poly count by culling out all the geometry which is not in use by the engine. Next is reducing the splits. So having minimal amount of splits in UV will essentially also reduce your vertex count. Also, having soft normals, as it is supported by engine by default, will also reduce your vertex count. Next is having a material order. This is essential if you are doing a modular workflow. In this case, if you want to replace materials in masses, you can just replace the materials in the slot and you will have the completely different look for your asset. Textile density is one thing which is very important. This will ensure that everything in your game will look at same scale and the player will not feel out of place. And also reduce the distortion, pixelation, etc. And last is additional UVs. This is only for those who are using baked workflows. Yes. LODs are very important components of any authoring workflows. If you want performance, it is must you should have LODs. At Indus, we have multiple set of LODs and multiple custom-made LODs for us. So first and foremost is the mesh LODs, which are authored by artists when they create assets. Then we have the custom set of LODs. HLODs is, for example, LODs for a group of meshes. You group certain amounts of meshes and create LODs for them. Then we have billboards, which is essentially mostly used for foliage. This is essentially camera-facing planes. When the player is facing some kind of asset, the planes will turn according to it. And last, we have custom LODs. So this is what we have in Indus along with all the others. Stack LODs is LODs for groups of LODs, which is one step higher than the HLODs. Next. You need to have some kind of export checklist. This is one we have in Indus. So each and every DCC software like Blender, Maya, 3ds Max have its own set of parameters, orientation, and scaling system. So Unity has to do a lot of grunt work to convert this. So having a unified system for scaling, access orientation, pivot placement will help you to reduce the overload you have inside the engine. And it is also very scalable if you have to provide the files to someone else. Next is cleanup. Cleanup should be an SOP. It should not be an afterthought. Everyone should do cleanup. There should not be split meshes, etc. inside your game. Now, nomenclature is a must. I know we are artists, we are focused mostly on creative aspect, but nomenclature is very important when you're handing over meshes to engineers. They have to make some changes, they have to do something, you have to have custom tool. Nomenclature will be a lot helpful when you have an identifiable set of naming scheme to batch all the operations. Next, we talk about authoring the textures. Just as we did for modeling, we need to understand what type of texturing workflow you are going to follow. There are, I've listed down 3 essentially mostly used texturing approaches, but there are many. First is the unique approach. Unique approach is essentially tackling each asset by itself, creating its own unique UV set, and then authoring the textures inside any software like Substance Painter. So one of the drawback of it is like if the asset scale is too huge, you have visible texel density issues. Second, we have tileables, which is mostly used in most of the environment aspects. Just because of the sheer sheer size of the assets, you can just wrap around these textures and have multiple iterations over it through shaders. Third is the atlasing workflow, which is very common if you see in mobile games. In this, you can just pack multiple sets of textures, models, or model UVs, and tileable textures in one atlas, and just keep sourcing from it. This is performant, but at the same time, there are some strict UV concerns over here, which will essentially increase your poly count. Next, we have creation. So there are essentially 3 type of approaches when you create assets. First is the classic approach. This is very, if you see, all the hand-painted texture, etc., are done using this approach. This is very helpful in creating textures which need to have painterly art style, etc. Second is the assisted workflow. Assisted workflow essentially gives, like Substance Painter, etc., gives you tools out of the box to do some of the work for you. They have helpers, generators, which will help you assist you with creating textures without you have to manually doing it. And third is the procedural workflow. At Windows, we mostly use Substance Designer to author most of our textures. Essentially, we have a group of plugins or set of subgraphs created in which we only have to supply height maps, and all the textures are just generated by themselves. Next, some of the helpful tips while considering the devices we are targeting. So mobile devices essentially have a very small screen, and even in your baseline devices, sometimes you will have to turn off anti-aliasing. So having two contrasting details side by side will cause a lot of shimmering if a player is playing your game. So it needs to be avoided. Second thing is MIP maps. So if you're not using them, MIP maps are essentially Lord groups for your textures. So having this will essentially give you a sense of scale depth, at the same time will not cause any anti-aliasing issues. Lastly, rendering. So rendering is essentially how the game is going to look based on your textures. So first thing first, the diffuse workflow is what most of the previous generation games used to do. It is just taking all the detail maps and baking it into a single texture. It is very performant, but at the same time, it looks very flat. Second is PBR. PBR will give you most accurate representation of materials, how you see it in real life. But one thing to consider is it will have a lot of maps generated, and you will have to essentially have a large pool of textures. Third is the custom. At Indus, we have our own system of textures, custom packed, baked, etc., which we just source and tailor make for our game and work with the shaders that are compatible with these. While we are on this, let's talk about channel packing. So one of the key things to do while creating textures for mobile games or any other games is to reduce the texture count. How can you do that? So you can just pack multiple textures in different channels of your RGB texture. This will essentially save you more time, more budget, and give you more creative freedom. There are some advanced channel packing tricks which we used in Inters. It is essentially range packing. We pack different amounts of range in single channel, so we can have up to 9 textures in single RGB channel. Now, now you've done everything. You've created your asset, you have authored your textures, you have integrated it. Let's talk about how do we test this. So most of your gameplay will be, most of your game will be rendered using shaders. Shaders are important part of any of your workflow. Shaders will define how your game will look. You can have cell shaded to stylized to hyper realistic using your shaders. Second is shader will help you read the custom maps you have. Custom maps are essentially whatever you authored in last slide we saw. And third is it will help you to create visual effects or any other rim lights, etc. effects for your game. Example for this is holograms, etc. You can create using shaders. But keep in mind, each shader will essentially be adding expense to your performance. So now we have it. Let's look at some of the tools that can help us reduce poly count and increase performance. First is frustum culling. As most of you would have noticed, this is a very famous screenshot, GIF from Horizon. Frustum culling is there in every engine by default. It is already on. You just don't know it. Use it. Second is the manually authoring of the culling. So occlusion culling is essentially something which will just render objects which are in your current view and discard all the other objects besides that. This requires some manual setup and testing, but yeah, it will help you boost your performance a lot. Third is the distance-based culling. This is essentially like LORDs, but it can be custom authored. Now, how do we set up our testing? First thing first, we just spam the scene with all kind of objects we have. This object, that object, emissives, renderers. Every kind of object you have, just spam it inside the scene. Apply all the shaders. And then just do a optimization pass, like apply your custom culling, occlusion culling, and LODs, and just profile it. So at Indus, we use Unity. It has some handy tools. There are equivalent of that in other engines as well. First and foremost is the frame debugger. It will essentially help you to debug a frame capture of your game and see how the objects are being rendered in in a stack. One by one, you can go through it and check where the problematic areas are. Next is profiler. Profiler essentially will capture a data while you are playing the game. This can be done on device as well as on your system. So it is recommended to do on device. This will give you all important metrics to make changes and improve your game further. This will have poly budget, textures, material count, and CPU and GPU usage. Last but not least is profile analyzer. This is very important when you have made any changes inside your scene, and then you have to check if there is any performance gain or loss. This lets you compare two sets of data and see where the changes are happening and what to do further on. Last but not the least, enjoy the process. It's not everyone. Large task doesn't mean we can't have any fun. At Indus, we do create some of the memes, as you can see, while creating our tasks. And some of the closing thoughts. At Indus, limitations is like a playground. We all enjoy it. We just play around it. We have fun with it. On closing notes, just keep some of these things in mind, especially the last one, if you have experimental teammates like me. Thank you. Indus Mafia signing off. Do check out Indus booth. We have it on GDC. Cool. Any questions?
Thanks, Saurabh, for the insightful talk. Any Q&As?
He has a question.
Hello. Very interesting talk. I got a question regarding how you scale between all the different platforms. You mentioned having different shaders or different LODs, but do you actually ship different models or like different versions of the shaders?
So at Indus, what we do is, so we know how to, we will require to scale the game to console level quality. So what we do is we start creating assets from that standpoint. So we create the asset at the fidelity of the console, and then we start authoring LODs for it. So if the LOD 0 is console quality, we just use LOD 4 and below as mobile game quality.
Okay, great, thank you.
Yeah. Any more questions?
Hello, very nice presentation. Thank you for that. So I have one question where you mentioned about using modularity and a combination of unique assets for making environments. So one question is like, so when you are using modularity, there will be repetition, which you can break using decals. So you can make variations in two assets. But since alpha will be costly, draw calls might get bigger. So how you tackle all those? So using shaders or like?
Yeah, that is technically the thing. But first thing foremost, you can just have add-ons for the assets. So decals are expensive. For that exact reasons, we have models with just unique assets which we use as add-ons on top of the core elements. So modularity will have single asset tiling all over. But you can have different sets of add-ons like sci-fi set, Indo-futuristic set, or any other set, which you just stack it on top of the base shape, and it will essentially break all of what we call repetition. Decals can be used. In that case, you will have to ship a custom shader in which you blend two materials. First material will be the base of whatever texture you are using on your wall or any modular surface. And second texture is whatever decal you want to use. Cool. Another? Yeah.
Any other questions? I guess that's it.
Yeah.
Thank you, Saurabh.
Thank you, everyone.